Hey guys, oh sorry about that. How's it going? It's great to be back. I know I haven't posted in a while, but we're back and we're ready, to keep grinding and all that. I do apologize for the late posts. It's been hectic with school and everything, and just trying to stay on top of it and also trying to keep giving you guys quality content that matters and helps all of us grow as a group. So I'm Lightning Code, if you didn't know. I'm going to be covering a topic that's like a continuation of the last video I posted, the linked list video. Today we're going to be working on reversing a linked list. So in essence, we are taking, and if you've noticed, I have my, I have OneNote open because now I'm trying to make the videos more visual. I mean, they're videos, but like explanations more visual with like drawing out things and just making it easier for everyone to follow along. So we want to take a linked list like this that has next pointers and nodes, and this is pointing to null. And we want to reverse it so that it becomes this. And we want to do this, there are many ways to do this. You can use a stack. That's the first method I ever used to understand it. I used the stack, put everything in the stack and start popping from the stack and copying it into a new linked list. That can work, it definitely works, but there's also a more efficient way of doing this just by going in one pass. And that's the way I'm going to be covering now. So let me just select this. Is that the select tool? That's probably not the select tool. All right, I'll just redraw it here. All right, so what we want to do is, for this method, we are going to need 3 pointers. We're going to need a previous pointer. We're going to need a previous pointer that points to none at the beginning, that initializes at none. We're going to need a current pointer that points to the head of the linked list. So we're just going to use H here to point to this. And we are going to need a next pointer that points to to current.next. So that's going to point here, current, the next, and it's going to point here. This is where our next pointer lives. So essentially what we want to do is we're going to follow like a pattern, like a cycle. So that way we'll be able to hit every node, and we need to be very careful when we're reconnecting these next pointers, because that's how we're going to reverse it, by reconnecting the next pointers to the previous node. We need to be very careful that we always have something pointing to whatever node that we're going to be working with, because the moment we don't point, the moment we lose a pointer to a node, that node is gone forever. And we don't want to send a node to the computational abyss and just leave it in memory so that it gets deleted. That's not really fair. So here's what we're going to do. We're going to start, so it's basically a pattern. So we want to point the next pointer to current.next, so that's going to point to the next node that we will use in this loop. That's like what we're going to, so but the current node we're working with is going to be 1 in this case, which is the head. So that's what we're starting at. Now we want to take this pointer, let me just use a different color. This, that doesn't show quite well. Let's use galaxy color. This pointer, we want to take it and move it here to point to this. Now, I will redraw it so that it's more visible. So basically what we want to do is we want to take the current pointer and make it point to the current.next pointer, and make it point to previous. So basically this is still previous. I'll just write prev there. This is our current pointer. This right here is current.next, and it's pointing to previous. This is 1. And notice that though we have disconnected this node from what used to be connected to it, that's the 2, we still have our next pointer keeping track of that. So now this is connected. Now this is where it can get a bit tricky. If you move the current pointer to next, this guy has nobody pointing to him anymore, and then we've lost him. But what you have to, because it's sequential, you need to be very careful what you're doing first and what you're doing next. So we want to move the previous pointer to point to the current. So previous will no more be pointing to null here because we still have this null because our current.next is pointing to null. So now we have, this is kind of like what we have going on now. So this is, sorry, let me erase that. Yeah. So we have our current.next pointer pointing to null, and then we have both previous and current. So this is previous and this is current pointing to our head pointer, which is 1 in this case, but it would be something else like as you iterate over the linked list, pointing here. And we still have our next pointer here. So we have successfully reversed this. We have successfully made 1 points to the thing behind it. So that's a flip. Now for us to move on to the next thing so that we can flip 2, we are going to set the current pointer to point to the next, wherever the next pointer is pointing to. And how that's simply getting rid of this and basically moving it here because we have this next. So once we do that, within our while loop is still going to be checking like is current null. So our while loop will say, okay, current isn't null. Fine, let's advance the next pointer. And then the next pointer moves forward. And then we're essentially back to where we started, like kind of like right over here. In the sense of the previous pointer is what comes before the current pointer, and the next pointer comes what points to what comes after the current pointer. So you can see the general flow and do the same thing. Make current.next point to previous. This goes away and it flips. Let me just draw the sequence. It comes here. So we now have this pointing this way. We have that. And now we have previous going to point to, sorry, previous going to point to our current pointer. So we have previous here. Then our current pointer is going to move over here. So then we just get rid of that. I'm just going through the general flow so that it's like very visual. Feel free to slow down, pause the video, rewind, just so that it's really clear. And then we're pointing to this. And then we have our next node, which is 4, which is null in this case. Let me use null. Yeah. So that this doesn't go on forever. And then next is going to point to null. And this is in writing. Nice. So we're essentially back to where we started. And just so that I go over and like show you guys how it actually breaks out of the loop, we are still checking if current is null. And because of the way we're going about it, after we do our regular flipping, you know, previous moves over here, and then current will jump over to next in our regular fashion. You discover now this is the point where, okay, our while loop checks, is current null? So let me indicate this as the head pointer because this was our initial head pointer. And current is null. And it's like, all right, I'm breaking out of this while loop. So now we have effectively reversed this. As you can see, this is a really good, this is actually reversed. This has reversed it, and next pointers are pointing in the opposite direction, and everything is linked properly. But we have a problem. This is now our head. We don't want that. We reversed it. So what we're going to do, oh my God. So what we're going to do is move the head pointer to point to whatever the previous pointer is pointing to. That was a lot of pointing, but So basically the head pointer is going to point to whatever previous is pointing to. So that's this. And this will always work because previous is always going to stop at the last node with data in this linked list. And that's how we're going to be able to always access it. So we've effectively gone from this. We've gone from this to this. And that was, so you can see it's really straightforward. We didn't need any extra data structures to store temporary variables. We're just flipping and keeping track, using pointers to keep track and maintain access to each of our nodes. So this is the conceptual part. Let me hop into the code real quick. So I've already written the code, so I'll just walk through it. So we have the previous pointer starting at pointing to none, and then we have the current pointer starting at pointing to the head of the node. Sorry, the head of the linked list. So while current is not none or isn't null, we're going to make the next pointer points to current.next, and then make the current.next pointer point to previous. So that's exactly what we did here. In essence, that's what we did here. The whole current.next pointing to previous, and now we're going to make previous points to current. So previous now points to current, and current will now point to next. And this goes on. You can see this is within the loop, and then just outside the loop we have the list.head will be equal to previous. And this works really well. Let me show you what the list looks like before we run it. So this is our initial linked list 1 2 3 4 5, because that's how it is. And then once we use the reverse function that we just wrote up here, we see 5 4 3 2 1. So I really do hope that this was helpful. I hope you have a better understanding of how to reverse linked lists. This will come in handy in solving LeetCode problems like adding two linked lists and returning another linked list as a value. In that, you can, if you're doing any other problem that involves you flipping, rotating, or reversing linked lists, this little piece of code will help you do it really fast and will really take away a lot of the excess time that you might waste storing them in temporary data structures like a stack or an array and all that. So I really hope you enjoyed this video. Please leave a like if you really enjoyed it. Remember to subscribe if you haven't, because what you're waiting for. And feel free to leave a comment about what you think I could do better. Let me know if you prefer me to write the code, then explain with the drawings. If you like the drawings, if you don't like the drawings, just let me know what you guys like, what works for you, and we can figure something out that we can keep using as a standard for this channel. And also remember, please send me any coding challenges or any LeetCode or HackerRank problems that you might come across that you feel like, oh, I think we should all like solve this together. So remember to keep doing amazing. You guys are doing great. I'll see you guys next time.